In this lecture, we're going to look at dynamic arrays. And these are arrays you can allocate on the heap, and they're not going to be stored on the stack like we have seen before. The arrays we have learned about so far have been living on the stack. We want to see how we can allocate arrays on the heap if we happen to need that in our applications. Arrays are allocated on the heap with the new operator. We can also use the std no throw version of the new operator if we don't want exceptions in our C++ programs. Here is a simple example of how you can do that. We have a pointer called psalaries. It's going to be a pointer to double, and it is going to contain the address to the dynamic memory that we allocate on the heap, which is going to contain an array of doubles of this size here. Okay, this is an array that is going to be initialized with junk values because we are not initializing that explicitly. So this is something you need to be aware of. Okay, pstudents is also going to be containing the address of an array that is going to be allocated on the heap. We are using the std no throw version of the new operator because in this case, for example, we might not want exceptions. And we're going to say that it is an array of events. It's going to be this size, but we are using braced initializer. So this is going to be initialized to 0. All the values inside are going to be initialized to 0. This is what we mean here. We also have a p-scores array. We are using the std no throw version of new, and it is going to be this size and initialized with 1, 2, 3, 4, 5. Okay, if the array is bigger than 5, the remaining slots are going to be initialized with zeros, just like we saw with the arrays we have learned about previously that were stored on the stack. This is really how you work with these things, and I hope it is super clear. Again, we are calling the new operator. This is going to allocate however memory space is needed to store these things on the heap. So if this array is going to contain 10 elements, we're going to allocate enough space to contain 10 double elements on the heap, and we're going to be pointing to that with the psalaries pointer. That's what we mean here. Once you have your dynamic array allocated on the heap, you can try to do things with it. For example, we can try and loop through the scores and print them out. Here you see that we are using the angle bracket syntax and the pointer arithmetic syntax. It is going to work equally well. You can choose whatever you want, but I just wanted you to see that you can use both versions here. The next logical thing to think about when you talk about dynamic memory allocation is how you release the memory to the operating system when you're no longer using it. And this is the syntax to do it with arrays. You say delete, you put angle brackets, and you say the pointer that was used to allocate that memory in the first place. And after you do that, you have to remember to reset the pointer to null pointer because you are a good C++ citizen. And this is really all we had to say in this lecture. This is how you dynamically allocate arrays on the heap. Before we head over to Visual Studio Code and play with this though, I want you to keep in your mind that arrays you allocate dynamically on the heap are very different from the arrays that we have learned about before. And that's because they don't work with std size and they don't work for range-based for loops. And the reason for all these limitations is that when you do something like this, the array really decays into a pointer and it loses information that would otherwise be used to deduce the size that is used by std size. And there are other things that are used by the range-based for loop that they lose when you store and refer to them using a pointer like this. That's why we have this limitation. Keep this in mind if you are using a dynamically allocated array on the heap. You're going to be using other techniques to deduce its size, and it is not going to work with a range-based for loop. So we will have to use other kinds of loops that we have learned about in this course, and it is going to work pretty well. This is really all I had to share in this lecture. Now I think it's time we went to Visual Studio Code and actually tried this out. Here we are in our working folder. The current project is dynamically allocated arrays. We are going to grab our template files and put them in place. And we're going to put that in the current project and open this in Visual Studio Code like we always do. And we are going to go down and put in some starter code we can play with here. We're going to click on this file icon to remove this pane. And we're going to try and show the code here. And again, you see that Visual Studio Code is freaking out when it sees the std no throw version of the new operator here, but it is going to work when we hit the compiler. Okay, so we are allocating 3 arrays on the heap dynamically, and we are going to be storing the addresses to these arrays and these pointers. For example, p salaries is going to store the address to this dynamic array, which is going to be living on the heap. And it is going to be the same case for p students here and p scores. I don't think there is much to explain here because we have already learned about arrays. We know about the size of an array. We know that it is a piece of contiguous memory location that is going to be storing variables of the same type. This is really what we're going to have. So let's try and compile this and see that it actually goes through our GCC compiler. And it is going to work fine. And another thing you should notice is that this is really compiling even if what we are using to store the size of the array is not const. Remember, for stack arrays or static arrays that we had on the stack, we had to make sure this guy here is const. Okay? That was a requirement. And if you didn't fulfill that, your code wouldn't compile. Now you see that with dynamic arrays, the code is actually compiling even if it's not const. And this is something you should be aware of. Let's build this again. I just messed up my things here. And the build is good. If we go down and run it, we're not going to see anything really because we're not having any output in this program. But this is how you can allocate space for a dynamic array on the heap. Now let's try and print some of the data in this scores here. Let's go down here and actually do that. We are going to do a null pointer check because we want to make sure that memory was actually allocated for the p scores array. And after we do that, we're going to look for size times, and we're going to be printing whatever element is at each iteration, the index at each iteration. And you see that we can either use the angle brackets notation or the pointer arithmetic notation. It is going to work equally well. If we build this, let's bring up our terminal. We haven't opened one. And let's go down and clear and run Rooster. You're going to see that successfully allocated memory for scores. And we're going to be printing the data. First, using the angle brackets notation. Second, using pointer arithmetic. And you see that it is working pretty well. One thing you should have noticed now is that we haven't actually released the memory that we have allocated here, and this is something really bad. So we're going to see how we can do that. We have allocated space for salaries, p students, and scores. So let's go down and do that, and we're going to say delete. And we're going to have angle brackets because this is an array we are releasing memory for, or to be exact, a dynamic array which was allocated on the heap. So we're going to say p salaries, and we're going to reset that pointer to null pointer because we are good C++ citizens. So we're going to do that, null pointer, and we're going to do the same thing, delete. We are deleting space for a dynamic array, so the angle brackets here, the square brackets, I should say, and we are going to delete p students, I think. Yes. So we're going to say p student, and we're going to say p students, and we're going to reset this to null pointer, and we're going to do the same for p scores. Let's grab this here. That's what we want. No, that's not what we want. We're going to say delete and say square brackets ourselves, and we're going to say p scores, and we're going to release that and say p scores and reset this to null pointer. Now we are really playing it safe, and our program is going to release the memory that we allocated in these 3 statements here. If we build the program, it is going to go through well. So we're going to build with GCC, and we are going to clear and run Rooster, and it is going to run pretty well. You see that for p scores, we initialized the first 5 elements, and the remaining elements were initialized implicitly by the compiler to 0, and you can see that here. I don't think I explained this, but this is my chance to explain this. I hope you understand. The next thing I wanted to explore before we close this video is the difference between static arrays and dynamic arrays. A static array is an array you allocate on the stack like we have been doing before, and you do it using a syntax like, let's say, scores, why not? And it is going to be an array. Let's say it is going to contain 10 elements. And we are going to put in our values in the format that we know. And we're going to go all the way to 10. Let's put in a 10 here. And we're going to end this with a semicolon. This array is cool, and you can loop through it. You can do all kinds of crazy things with it. But I am going to emphasize two differences we have with dynamic arrays. One is that this guy is going to work with std size. So we're going to say cout. Okay, this is going to work. If we compile this, we're going to get a good build. At least I hope. Yes, the build is good. And if we run Rooster, we're going to get scores size is 10. The other thing is that you can use a range-based for loop to loop through this guy here. So for example, we can say for auto score, S for score in scores, and it is going to work. So let's go down and say what we are doing here, or we can even say a single line to separate things here. I don't want to be confused, so I am going to do something like this so that I know where my output here is going to start. So I am going to build this with GCC, of course. The build is going to go through, and if I clear and run Rooster, I am going to see that the size is 10, and I am going to print my elements here with a range-based for loop. Okay, let's see how these things behave when we use a dynamic array. We are going to set up a similar array, but on the heap, which is going to live on the heap. This array here is the static array in that it is going to live on the stack. You have to be aware of these differences. Okay, we're going to do another one which is going to live on the heap. And the way we do that, we say int pointer. Let's say pscores1 to make sure this is different from pscores that we have on top here. And we're going to have 10 elements inside. And we can even initialize this guy exactly like we are doing here. But the data is not going to live on the stack. The data is going to live on the heap. If we do something like this, first, let's make sure that the code compiles. We're going to try and run this through GCC. And watch the compiler output here. The build is good, so this is valid C++ code. We can try and use std size on that, and we're going to go down and do that. And if we do that, we're going to say pscores size, 1 size, and say pscores. If we try to pass this pointer here, you're going to see that Visual Studio Code is going to freak out because this won't work. The array here has decayed into a pointer when we refer to it using a row pointer like this. So we can't really use it inside std size. So if we look at this, we're going to get a weird compiler error, but this is going to be the problem here. Okay, so you can't do this with dynamic arrays. This is one limitation. The other is that you can't use dynamic arrays like we are using a range-based for loop here. So if we grab this loop and try to work with it on pscores, for example, this is something somebody might want to do. Let's say pscores1, okay, and try to print something inside. You're going to see that this is not going to work. The compiler, Visual Studio Code, is not going to like it first. And if we try and run this through GCC, we're also going to get a weird compiler error. And the problem is going to be that pscores is really not an array. It is just a pointer that is pointing to some location in memory. That's all it is. And it doesn't have information that could be used otherwise to loop through elements like we can do for a real static array that is living on the stack. Again, let's be super clear here and say that this array is going to live on the heap. You have to understand these things. But this is really not a big limitation because you can store the size of this guy in some variable and refer to it if you need that. And you can loop through the array exactly like we did here using size and it is going to work pretty well. So don't be afraid to store your arrays on the heap if that's what you need in your application. It is going to work pretty well. You just have to be aware of some limitations that come with doing things this way here. This is really all we set out to do in this lecture. I hope you have a better idea about dynamic arrays. You set them up like this. The size here doesn't have to be const like we have with static arrays, and they have a few differences compared to static arrays that were stored on the stack, in that std size doesn't work for them, and they don't work with range-based for loops. Other than that, dynamic arrays are really cool, and you should use them when that helps whatever it is you are designing. This is really all we set out to do in this lecture, and I hope you found it interesting. We are going to stop here. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.